Recall the main idea behind hypothesis testing. The more extreme your sample mean is, the stronger the evidence you have against the assumption. Null hypothesis is the assumption. Why? Because if your assumption were true, then such an extreme sample mean would rarely occur by chance alone. In other words, randomness cannot explain entirely why you would have a sample mean so inconsistent with the assumption. Now, all these words extreme, rarely, we have to quantify them. So, after we set the hypothesis, what we need to do is to find some kind of tail probability. To do that, we need to find a z-score. After that, we can draw a conclusion in plain English. To quantify how extreme or how rare a sample mean is, we're going to calculate a z-score. We call that a z-test statistic by using this formula. And then we're going to find a p-value. P-value is just a probability number. Now this p-value depends on z, of course, but also depends on the types of hypothesis tests that we have. So there are 3 different types. So let's use our usual example to illustrate. Let's say everybody says that it takes 4 years to graduate. So mu is the average graduation time for a college student. So mu is 4. If the researcher believes that mu should be less than 4, then the alternative hypothesis should be mu less than 4. Now, so let's say I'm the researcher here. So before I even go out and collect data, in my mind, I expect that the sample mean will be less than 4. Or I'm hoping there will be less than 4. In other words, let's say this is my sample mean. In other words, if mu is true, so we assume that mu is true, my sample mean will be on the, let me get rid of that. If mu is true, mu is here, I'm hoping that my sample mean will be smaller than mu. So my sample mean will be on the left-hand side of mu. So this is my sample mean. And this tail probability, this is the left tail probability, is called the p-value. So a p-value is just a probability number. In this case, it is the left tail probability. It represents the probability that if mu is true, what's the probability that I will get a sample mean as small as mine, or even smaller? Even smaller, meaning their other sample means are smaller than mine, right, on the left-hand side. So p-value is a probability number that tells me how unusual our sample mean is if mu is true. So if mu is really here, true, is here, mu is true, how rare is my sample mean? That means what are the chances that I will get a sample mean this small, like mine, or even smaller? So this is the p-value. So to find the left tail probability, we need to find our z-score and look up the table, and then we will get our p-value. So when we have a less than sign in the alternative hypothesis, our p-value is just the left tail probability. So this type of test is called the left tail test or lower tail test. If the researcher believes that mu should be greater than 4, that means in the researcher's mind, let's say I'm the researcher, before I go and collect data, I expect that in my mind that the sample mean is bigger than 4, right? And my alternative hypothesis is mu bigger than 4. In this case, when I draw a distribution diagram of x bar, my sample mean will be, and hopefully will be, on the bigger side of mu. Mu is here. I expect sample mean to be bigger than 4. So the sample mean is on the right-hand side of mu. And the p-value is going to be the right tail probability. So the p-value, in this case, because I have the greater than sign, is the right tail probability. And this type of hypothesis test is called the right tail test or the upper tail test. The last scenario, if the researcher believes that mu is different than 4, that means the alternative hypothesis will be mu not equal to 4. In other words, as a researcher, I don't know whether mu should be bigger than or smaller than, but I just know that mu probably is not 4. So I expect that mu could be bigger than 4. I'm sorry, my sample mean could be bigger than 4, or my sample mean could be smaller than 4. It can go either way. When that happens, that means that my sample mean can be on the bigger side of mu, or can be on the smaller side. So in this diagram, I only draw the bigger sample mean, bigger than 4. It could also be on the other side, could also be here, okay? But the main idea is, so let me erase that first. So let's assume that, our sample mean will be bigger than 4. So on the bigger side of mu. Now, the key thing is, when we have this type of alternative hypothesis, this is a two-sided hypothesis because of the not equal to sign. Our p-value is both the the left tail, and also the right tail. Our p-value actually is the sum of the two tails. So let's say if I call this tail probability A, if I call that tail probability B, our p-value is equal to left tail plus right tail. So this type of test is called a two-tailed test. Now we'll use an example to illustrate this. So let's say my sample mean is here, bigger than mu here. So I will have a z number. And then I imagine I put a negative sign on that z number, and I'll get another tail. Take for example, if this z number is 2.51, okay? And I put a negative sign, 2.51. Then I will have two tails, and I can add up the two tail probabilities and get my p-value. So you have three different type of hypothesis test. The left tail test, you find the left tail probability. The right tail test, you find the right tail probability. And you have the two tail probability test. That means you find the sum of the right tail and the left tail. So which type of test you do depends on what the researcher believes in. So we'll use some examples to illustrate how to find the p-value for some of these hypothesis tests.